Welcome to the Explainer. So today we're going on a seriously high-energy journey into the absolute boundaries of mathematics. We're talking about exponential functions. These are those incredibly wild equations that describe things growing explosively large, or on the flip side, shrinking incredibly fast. We see them everywhere, right? In science, population growth, tech, and even finance. But here's the real secret about things that move infinitely fast. They still have to follow the rules. So let's dive in and uncover exactly what those rules are. Have you ever just sat back and wondered, how far can math actually go? Seriously, if something is truly growing exponentially, is it ever going to just hit a brick wall and stop? Or what about the opposite? If something is shrinking and decaying over time, does it ever truly completely disappear into absolute nothingness? When we start messing with exponents in math, we're basically dealing with the mind-bending concept of infinity. But the question is, can numbers just go on forever and ever? Or are there hidden walls, like invisible boundaries out there in the mathematical universe that these numbers literally cannot cross? Well, to start wrapping our heads around this whole idea, let's look at a pretty profound quote from Psalm 145, verse 13. It says, "Your kingdom is an everlasting kingdom, and your dominion endures through all generations." Now think deeply about that word for a second. Everlasting. It means infinite, right? And just like God's kingdom has absolutely no end, the boundaries of exponential functions stretch on infinitely too. But, and hey, this is a super important but here, they aren't chaotic. They always stay in this perfect, beautiful order. See, infinity in math doesn't mean some messy free-for-all. It actually means a perfectly designed system with crystal clear rules. Okay, let's get into the actual core rules that map out this mathematical infinity. We're talking about domain and range. You can think of these two crucial terms as the mathematical boundary lines that dictate exactly how far a function can go. They literally define what's mathematically possible, and maybe even more importantly, what is strictly impossible. Imagine an exponential equation is a giant factory machine. The domain? Well, that's all the raw material you're allowed to feed into it. And the range is the final product the machine is allowed to spit out. So let's break those two apart and see how they actually behave, because they're pretty different. First up, the domain. These represent your inputs, your x values. And for exponential functions, the domain is incredibly free. It's always all real numbers. That basically means if you're plotting a graph, you can move as far left into the negatives or as far right into the positives as you could possibly want. Plug in a million, plug in negative a billion, it doesn't matter. But then we have the range. These are your outputs, your y values. And unlike that totally free-spirited domain, the range always has a floor. It operates on an up and down axis, and it has a strict, hard boundary it absolutely cannot cross, no matter how hard it tries. To kind of visualize this, imagine you're holding a helium balloon. If that balloon is experiencing exponential growth, it's rising higher and higher up into the sky, just seemingly forever. Now, if it's experiencing exponential decay, the balloon is losing its lift. It's just slowly, gradually sinking back down. But here is the absolute secret of the range. The balloon never actually goes below the floor. In our standard math equations, that floor is zero. The sinking balloon gets closer and closer and closer to the ground until there's just this tiny microscopic sliver of space left, but it never actually touches it. The range ensures that y is always, always greater than zero. Now, it's one thing to talk about floating balloons and infinite kingdoms conceptually, right? But let's actually test these rules with some real mathematical examples, just to see exactly how this whole thing plays out on paper. All right, here's exactly what we've been talking about, but in action. Let's take a growth equation. Y equals 3 times 2 to the power of x. Because x is the domain, the input is all real numbers. Easy enough. And the range? Well, y is greater than 0. Now, let's look at a decay equation. Y equals 100 times 0.5 to the power of x. Here, every single time x goes up, the total value gets cut in half. It's shrinking really fast. But notice how the domain and range stay exactly the same. So whether your equation is growing to be infinitely massive or decaying down to some tiny microscopic fraction, the domain rule and the range rule remain mathematically identical. Pretty cool, right? Now, when you're rushing through your homework, your brain naturally tries to find little shortcuts. We all do it. But there's this one specific logical trap right here that catches so many brilliant students completely off guard. So let's make absolutely sure you don't fall into it. Okay, so a student might look at an exponential equation, something like y equals 5 times 3 to the power of x, and just kind of guess that because the domain is all real numbers, well, the range must naturally be all real numbers too. They just assume the graph is completely boundless in every single direction. But here is the truth. The range is strictly y is greater than 0. gotta remember our rules. Exponential functions never go negative. Honestly, they never even hit zero. It's like if you keep cutting a piece of paper in half over and over and over again, the pieces get infinitely small, sure, but they never completely disappear into nothingness. And that is exactly how the range works. So, to make sure you've got this entirely locked down, here is a super quick 3-step guide to just mastering your homework. Step 1. Whenever you're asked for the domain of a standard exponential function, just confidently state that it's all real numbers. Boom. Step 2. Ensure your range output is always written as y is greater than 0. And step 3. Just visualize the graph in your head. Remember that balloon. The line on the graph is going to sweep down, but it will forever hover just barely above the x-axis. It never ever touches it. Honestly, if you just internalize those 3 simple steps, you're going to confidently dominate absolutely any question on growth and decay functions. While we've spent all this time sharply defining the rules of exponential math today, but just like math has rules to keep equations from totally falling into chaos, life has rules too. And this brings us to a really deeply important philosophy from the Heroesmartacademy Godly Learners series: education without morality will hurt. I want you to just think about that for a second. What is the true point of being incredibly smart, of knowing the boundaries of infinity and acing every single math test, if we just keep making bad choices in our actual lives, choices that hurt ourselves or hurt our families and friends? A sharp mind is an absolutely wonderful tool, but without a solid moral compass, it can lead us completely out of bounds. And really, that's exactly why we anchor our academic journey in biblical morality. Romans chapter 8, verses 6 and 7 actually promises peace of mind to everyone who keeps their mind spiritual. When we intertwine our education with a spiritual mindset, we aren't just blindly memorizing facts to pass a test. We're actually learning how to live beautifully and peacefully. Keeping your mind spiritual and focusing on good, moral choices right alongside your incredible education, that is the ultimate key to experiencing true, lasting peace. That's been our experience, and it's exactly what happens when you engage deeply with this kind of learning. So I'm going to leave you with this final, really powerful question to think about. You now know that exponential functions have this boundless domain, yet they always respect the beautiful boundaries of their range. Will you have boundless potential too? So will you use your boundless potential to make choices that actually bring peace? I'm challenging you today to take your growing mathematical brilliance, combine it with a really strong moral spiritual foundation, and go make a massive positive impact on the world. Thank you so much for hanging out with me on this explainer today. Keep learning, keep growing, and I'll catch you next time.